Hello everyone, welcome to Harsh IT Lab. And after a long time, we will back again to complete our series on the book Network Warrior. And topic for the day is hardware side of the network engineers. So basically, those who don't know or not aware of the scenario, actually we are covering the book. This is called the Network Warrior. Everything you need to know that was not on CCN examination. And let me recall you again that this book particularly focuses on the topics or things that was not studied or that was not included in the topic of CCNA and mostly encompasses the practical application of the things. So we will so right now or today we will going to see a lot about the practical networking and particularly practical networking is like the modules and hardware side of things. What modules does a chassis switch contains of, or what kind of things? And first, as a disclaimer, that this is not my topic of expertise, and I have learned about these things first. So it may be possible that I'm not aware of all the things that I'm going to say. So please take my words as a grain of salt. And without any further delay, let's continue the second thing to our terminal. Starting with the virtual interface that are tied to a VLAN are called SVIs. We know what an SVI is. For example, even on a layer 2 switch, we know that it's a layer 2 switch. It only matters or compasses the uh, MAC addresses in terms of routing. Routing is not the correct word, the switching. But we can also assign an IP address to that VLAN. And VLAN actually act as a virtual interfaces. So they are called the switch virtual interfaces. We use IP addresses on a VLAN to initiate the inter-VLAN routing if a switch supports multi-layer routing or using a ROS configuration, which stands for router on a stick configuration. Okay. So the router in this switch is a daughter card on the supervisor called multi-layer switch function card. So basically this line states that in switches or in the earlier model switches, I don't know whether if this is true for the latest switches or not, but because the switching only has the capability to understand and handle MAC addresses, in order to get it to function as a multi-layer switch, just like a PC has PCI lane in order to expand its storage, its graphic capabilities, for example, Thunderbolts, etc. So we can add a daughter board which contains the routing capabilities, basically kind of router that is attached on a PCI or a super high speed lane. And that card is called MSFC, which stands for multi-layer switch function card. Next is on older multi-layer switches, switching is handled by the CAT OS while the routing part is handled by iOS. So this line assures that it is talking about the previous switches because the latest data center line of switches is basically Nexus switches and they run the NXOS, which we checked or studied a little bit in our previous video. So in modern switches, both routing and switching is handled by NXOS, just what I said. And in NXOS devices, SVIs are not allowed by default and they need to be enabled by using feature interface VLAN. So basically everything is disabled on a Nexus OS switch by default because it is like a bare bone Linux configuration. You yourself have to add stuff into it. So it makes it modular in nature and much lightweight than these older switches. Now, LLQ for QoS. Basically, LLQ is a terminology that is found in quality of service. So, quality of service is a special parameter that we add into the frame or yes, in frame. So, it can be prioritized over anything other. Next, we will talk about the RPS, which stands for redundant power system. Or actually, we don't have a lot of word in regarding RPS in the book. You have to go to the book in order to study whatever it offers. But I don't find anything amusing that I needed to share here. But that's your call. You can also check that out. Next is FEX, which is such inclusive thing because it takes a lot of time for me to understand what a FEX is. So FEX is like a switch, but it is not a switch. So let me explain. FEX stands for Fabric Extender. It is a technology which is used in networking that act as a remote line card for Cisco Nexus switches. simplifying network management and increasing port density without adding much complexity. The complexity that we are talking about here is of another control plane or management plane, because these fabric extender actually used to extend the data plane of the switch, so it encompasses much more interfaces than it originally arrived with. So without adding any complexity to deployment things, we can add a fabric extender and it will extend the data plane by adding more interfaces and processing power. Next is, it relies on parent switch for control and management function, making it a cost effective solution for data center. So basically, the parent switch is the one on which we are plugging or adding this line card.